All right, so we're back here in Blender and I want to go ahead and start setting up our file to create a really cool render using the textures that we just created in Substance Painter. But before we go and start bringing those in, what I'd like to do is I'm going to create a new collection and I'll call it render. And we'll give it a new little color there. And I just want to go and duplicate these three meshes here. So I'll hit Control C and Control V to paste those in so that we're not using the working files or the working low poly models to do our renders, because we're going to do some rotating and different transforms on this model, which might make it a little bit hard if we want to go back and do some updates to the mesh itself. So it's just better to separate these out. I'm also going to make sure that I have these three selected and hitting Control and F2 to bring up the batch rename. I just want to get rid of the low.001. So you can see I've entered that here under the find section, and I want to replace it with render so that I know now that these three are associated with the render collection. So it's just an organizational thing. We might notice too that when we duplicated these, it actually duplicated the material. So I just want to make sure that I set this all back to the tire. And then that way, when we close Blender and reopen it, because this has no active users, it's actually going to automatically get rid of this tire material for us. So we don't have to worry about that. But let's just make sure that we have our tire on these meshes. And now we're good to go to set up the actual shaded material. So to start setting up the material now, let's head on over to our shading workspace up here at the top. And we'll see that we have that nice, beautiful, kind of color grid map here that we were using for unwrapping this model. But now it's time to say goodbye to that and actually start bringing in our cool looking textures. So the bottom here is our shading editor. This is where we're going to be doing all of that material, shader, texture setup. So we'll see that we have this orange node over here. This is that, kind of color grid image that we created. And we've plugged that into the base color of our principled BSDF node. So this is the master shader box or shader node. So we're going to be inputting all of our textures into this shader socket here, or the shader node. So our first one is our base color. Since we already have that plugged in, let's go ahead and find our albedo texture. So I'm going to click the little file folder here, and I'll just make sure to select our albedo, and that should automatically set up the base color or albedo map onto our model here. So we're already off to a good start. Now I want to bring in our normal map. So let me just Shift D to duplicate that node here and bring it down to the bottom of that BSDF node, because that's where our normal socket is. I'm going to go and click on this again to find our normal map. And I'm going to make sure to select the OpenGL file format, because again, that's how Blender interprets its normals. So we can open that up. And I'll just click and drag and drop that into the normal socket. Now looking around our model, you might notice that it really looks incredibly terrible and not at all like how it looked in Substance Painter. So there's a couple reasons for that. We are using the correct normal format, again, if you're using OpenGL, but there's a couple things we need to do in Blender to set up our shader to interpret a normal map. The first thing we'll notice is that the output socket of our texture node is a color image format or a color format. We can tell that because of, one, the name is color, but also the color of the socket. So this little circle here and the little noodle coming out of it is a yellow color. Whereas going into our shader, it's looking for a vector format, and that's determined by this bluish color. So Blender's trying to do some kind of like calculations and transferring of data into the expected format, but it's not doing a really good job. So instead, we do have a node in Blender here to allow us to make that transfer of data a little bit more interpretable for what we're looking for. So if I hit Shift A again and go to search and start to type in normal map, we're going to want to use this normal map. Now, if I just backspace a little bit, you'll see that we have this normal node as well. That's going to do something similar, but it's not going to be exactly what we need. So make sure that we're selecting the normal map node. So now if we have this node in our scene, we'll be able to see that the left-hand side with our input socket is going to be color, and the right-hand side or our output is going to be that vector normal format. So if I drop that onto that connection, right, yellow to yellow, blue to blue, it's going to look a lot better in our 3D view, but we're still not quite getting our information perfectly correct. You'll see that it's kind of shiny and it still looks a little weird, like it doesn't look exactly like how it did in Substance Painter. And the reason that is, if I come back to our texture socket or texture node here, and I just zoom in, the way that normal maps work, it's using the RGB image channels individually to calculate the vectors for the lighting so that when light hits our model, it knows which direction to bounce off. So it's not using the full color composition of the normal map. So we need to tell Blender and this node specifically that we're not using this as a color image, but rather individual channels that are being composed together at the end of the day. So what we're going to do is, instead of selecting sRGB as our color space, we're going to go and select non-color. And you can actually even see in the tooltip that it recommends this file form, or this color space for normal maps specifically. So we know that we're on the right track here. So when I go ahead and do that, now this is going to look a lot better. And then finally, let's go and just Shift D to duplicate and bring in our RMA map. So we can navigate to the RMA and open that up. And again, like we were doing with the normal map, we want to tell Blender that this image isn't really being used for the final color composition, but rather the individual non-color or grayscale channels that comprise this image. So changing the color space again from sRGB to non-color is going to set us up at the start here, but you'll notice that it doesn't change the ability to actually select individual channels. So I can't just go and start to plug in color to metallic, color to roughness. It's not going to work that way. We're telling Blender that, we want to interpret these as individual channels, but we still don't actually have the specific access to those channels by default. And unlike the normal map, we don't have a node specific to our roughness or our metallic sliders. The normal map is a little bit of a unique, one-off case here. So instead what we'll have to do is I'm going to search for a separate RGB or color, I guess node is what it's called. So now if I bring this in, we'll be able to individually select the red, green, and blue channels. So I can plug in the red for our roughness, the green for our metallic, and now we might be tempted to actually find somewhere to plug in the blue socket to, but as we take a look on our shader here, we'll see that there isn't actually an ambient occlusion input. Now in Blender Eevee, the render engine that we're using right now to display this tire model here with all of its textures, there currently is no way to actually utilize the ambient occlusion texture maps. Now, that's generally more geared towards game engines, so just be aware that we're not going to be utilizing that specific texture slot in Blender necessarily. Now, to get around that, we're going to be using post-processing ambient occlusion. I'm going to bring my shader down here. And if we take a look in the render properties, which is this little camera button, you'll see that pretty much the second option here is this ambient occlusion. And when I turn this on, hopefully you can kind of see what's going on as it's starting to darken the image just a little bit in those kind of recessed cavity areas. If I click on this factor and do something like 20, right? This might kind of better highlight what's going on, is it's just kind of adding some darkness to some of those cracks or those crevices. Now, something like 20 is a little too extreme. I find that I kind of go around 2. I think 1 by default is a little too light. But this is just going to help boost those shadow areas just a little bit better, so that when we get to the final render, we're going to have a little bit more occluded areas based on the concavity of the geometry.